All right, good morning, good afternoon, good evening, ladies and gentlemen. Yeah, so if you haven't already subscribed to the channel and leave a like for this lesson. So now in today's lesson, we are looking at circuits. We already started this topic, and for my class, I am just going to give you some hints so that you just understand the basics and you'll be able to solve questions by yourself. So under circuits, what I want you to know is the array of resistors in parallel and in circuits. So if there are junctions, a junction is where three lines are meeting. Okay, if there are junctions towards resistors like that, then the junctions rejoin again. We say these resistors are in parallel. Okay, so whenever there are junctions and there are resistors at the end of those junctions, we say the resistors are in parallel. Then if the resistors are joined back to back like that, we say these resistors, so if this is resistor 1 and this is resistor 2, we say that these resistors are in series. Okay, so that is how you're going to know the difference between the resistors in parallel and the resistors in series. So basically, for resistors in parallel, there will be a junction where three wires are meeting, then they separate to the resistors. For series, there is no junction towards the resistors. Okay, so I'll give another example here. So maybe you have like that, something like that. Then you have something like that. Okay, so we see that there is a junction here where three wires are meeting and they're separating towards the resistors. So we say these resistors are in parallel. On the other hand, if we have like this, okay, so here these resistors are in series because there is no junction. A junction is a point where three wires are meeting. So here, this is just a corner here, it's not a junction. So these are still connected back to back. So these resistors are in series. Now, you need to know how to find the total resistance for resistors in parallel and for resistors in series. For resistors in parallel, the total resistance is 1 over resistance total. This is equals to 1 over the resistor 1 plus 1 over the resistor 2 if there are more resistors in the same parallel. So here in this case we have resistor 1, resistor 2 only, but if there was an additional resistor in parallel with these resistors, say resistor 3 there, we would have included 1 over resistor 3 and so on. So this would be the total resistance in parallel. For series, this is resistor 1 and that is resistor 2. Then there is another resistor here, say resistor 3. The total resistance total would be equal to resistor 1 plus resistor 2 plus resistor 3. Okay, and what you should know is that when current comes in a series circuit, it will be the same throughout these resistors. So the current that will go through here will be the same as the current that will go through there, and will be the same as the current that will go through there. So that is current going through the resistor. And how you find this current in this, we know that current is equals to voltage over resistors. So in this case, how you'd find the current that will go through each of these resistors, it will just be the voltage of the battery over the sum of the resistors that current is going through. So resistor 1 plus resistor 2 plus resistor 3. Okay. Yeah, so that is how you'd find current here. Now, on the other hand, here current, when current reaches the junction, just as the previous video, it splits according to the junction. So here it will split in this direction. So this will be a different current that will go through this, which will be different from the starting current. And this current that will go into this junction will be different as well. We can call this current 3. And when it reaches this junction again, it has to split, so there will be different currents as they go through different junctions. Okay, now let's look at a question and see how we can apply these questions, because similar questions on this just involve finding current through a particular resistor. So we'll start with this example here. So we have let me start simple. So we have this battery. Okay, we have a resistor there, another resistor there. Okay, so if this is 2 ohms, and that is 3 ohms, and this is 5 volts, the battery is 5 volts, and the long side of the battery is the positive and the short side is the negative. And you'll be asked to find the total resistance. So you need to check, are these resistors in parallel or are they in series? So here we see that there is no any junction before the resistors. Then we conclude that the resistors are in series. So the resistance total in this case will just be the sum of the 2 resistors. So it will be resistor 1. We can call this resistor 1 and that resistor 2. So resistor 1 plus resistor 2. In this case, resistor 1 is 3 plus resistor 2 is 2, and that will give us 5 ohms. Simple and straightforward. Let's look at a parallel case. So suppose we have a similar setting. Okay, so we have a resistor there. So this is just a simple question, right? So we have the long side is the positive, the short side is the negative, and always know that current moves from the positive terminal going to the negative terminal. So we have something like that set up, and down here we have another resistor like that. Okay, so clearly here, since there is a junction for us to go to the other resistor, and here there is a junction for us to go to the other resistor or leaving the other resistor, it means the 2 resistors are in parallel because there is a junction going towards a resistor. And we've said a junction is a point where 3 wires meet, or more than 3 wires. So starting from 3 wires going up, that is a junction. All right, so here we can put this as maybe 4 volts, and here we can put maybe 3 volts or 3 ohms, and here 2 ohms. And we are asked to find the total resistance. So resistance total, remember, would have to be equal to 1 over resistance total is equal to the sum of the resistors in parallel. Okay, so in this case it would be 1 over resistance total would be equal to 1 over resistor 1, can be any of these. So we say 3 plus 1 over 2. So there we find the common denominator, which is 6, and this will be 5. So 3 into there, that's 2, and you add everything, it will be 5. So 1 over resistance total will be equal to, so simplifying this, I hope you are not lost here. Let me just scroll up. So here you find the common denominator by multiplying this and this, which gives you 6. And you say 3 into 6, that is 2 times 1, that will be 2. Then 2 into 6, that is 2 times 1, that will give you 3. So basically you add the 2, you're going to have 5. Then here, this is just the inverse of this. So for you to find the resistance total, RT, you just flip the numerator becomes the denominator, and the denominator becomes the numerator. so that is over 6, because this is inverse of whatever is here, so this will flip. So you can simply divide this into that, which will give you about 1.2. So this will be 1.2 ohms. Okay, so now you found your resistance total. You can find the current, the total current going through the entire circuits for both cases. Okay, so you use the resistance total to find the total current going through the entire series, or the entire parallel circuits. So for current total, we know that it's the voltage of the battery over the resistance total. Okay, and same applies here. So for series, the current total would be equal to the voltage of the battery, which is 5, divided by the resistance total, which is also 5, and the total current in the entire circuit will be 1 ohm. 1 amp, sorry, will be 1 amp. So now this 1 amp is the current that is starting here. So when current starts from the positive part of the battery here in this circuit, it is the same current that is starting here. And remember, current only splits when it goes through a junction. So clearly here there are no junctions, so the same current that is starting here is the same current that is going through this resistance. It's the same current that will go through that resistance, and it will be the same current that will go through there. So here a question that may be asked is, what current is going through this resistor? It will be the same current, which is 1 ohm. So here it will be 1 ohm. So the current there, it is 1 ohm. 1 amp, sorry, it will be 1 amps. Then same thing here. Since current only splits when it goes through a junction, so it will be the same current here going through there. So even here, the current going through there is 1 amp. So you might be asked for a series, you're asked to find the current going through a particular resistor. So it will just be 1 amp. Okay, the other way you could have found this, maybe for instance, if you are not given or if you had no chance to find the current, you might just be asked directly to find the current through each of these resistors. Okay, let me just erase this. So for series, for resistors in series, the current will be the same. So that is what you should remember. So for resistors in series, since the current will be the same, the current from the positive going towards these will be the same. How do you find the current through each of these resistors? So you know that current is equal to voltage over resistance. So for you to find the current through each of these resistors, the current here will be equal to the current here. So basically you're going to have voltage, which is 5, over this resistor 1 plus resistor 2, which will give you the same value. Okay, so for current going through resistors, you just note that the current is the same. Okay, now we come to current going through particular resistors in a parallel circuit. So here we said current splits. So when current comes from the positive, remember current is coming from the positive here, so let me use the red pen. So it is coming from the positive, and as it comes, so this will be current 1, for instance. So if this is current 1, as it comes through a junction, some of it will go this direction and some of it will go down there. So this would be, maybe we can say current 2, and this other one that goes there, we can even call it current 3. Okay, we can call it current 3. Okay, so this current 3 will go all the way there through this resistor, and this current will go all the way through that resistor there. Okay, so now you might be asked to find the current that is going to go through the 2 ohm resistor and the current that will go through the 1 ohm or the 3 ohm resistor. So first of all, you have to note that the current going through a particular resistor or a particular junction, this current 1, is actually equal to the sum of the currents that I've separated. Okay, so basically what I'm saying is this. So there is this current that is coming here, and when it goes through a junction, it separates into 2. So there is some that goes there and some that goes there. So the current that we started with is actually equal to the sum of the current that goes there and current that goes there. So that is something that you should know. Then now, how are we going to find the current here and the current there? So now here, this is what you need to note. The voltage of the battery will be the same on this resistor and that resistor. So that is what you should know. So the voltage of the battery will be the same on this resistor and on that resistor. So basically, to find current 3, which is going through this resistor, you just say current 3 is equal to the voltage going through that resistor over the resistance. So in this case, current 3, the voltage there will be 4, then over the resistance there is 3. Okay, and when you simplify that, we get 1.33 amps. So this will be the current that will go through that resistor. To find the current that will go through that resistor, which is current 2, you just say since the current that will go through there has the same voltage as the voltage of the battery, so you just say it will be voltage over resistance. So you find the voltage, which is 4 volts, over the resistance, which is 2. And when you do the math there, this will give you 2 amps. Okay, so this is the voltage going through the entire, this is the current going through there and there. And now we're going to prove to say these answers are correct. So we are saying current total, okay, which is the current we are starting with as current 1, is actually equal to the sum of the current that are leaving or that are separating. Okay, so in this case we had current 3 there and current 2 there. So the current that we are starting with, which is the total current, will be equal to, when we sum this, it will be 3.33. Okay, 3.33 amps. So that will be the total current. Now we can also find the total current using the resistance total. Okay, remember, so total resistance total. So current total is equals to the voltage of the battery over resistance total. So voltage, that would be 4. The resistance total, that is 1.2. This is what we found here. So 4 divided by 1.2, what are you getting? Okay, so let me just do it here. 4 divided by 1.2. 4 divided by 1.2. We get 3.3, which is the same as what we got, 3.33 amps. Okay, so that is how you basically find the current going through a particular resistor for parallel and for a series circuit. So in the first case, the current going through a particular series circuit is the same. So first of all, you find the total resistance. You use the total resistance to find the current. So you just find the total current will be the same current that is going through the 2 resistors. So here it will be 1 amp and there it will be 1 amp. So then here, for us to find the current going through each resistor, we need to consider the resistance and consider that the voltage does not change. Okay, so for resistor, the voltage for resistors in parallel, the voltage will be the same for all resistors. But for resistors in series, the voltage here, since the voltage, so the voltage here, voltage 1, will be greater than the voltage here because there is a potential difference here, or a voltage drop. Okay, so when starting, the voltage will be 5 volts. Then when it goes through a resistor, since a resistor reduces voltage, there will be a decrease in voltage. Then here the voltage will further decrease, but when you add these two voltages, it should give you 5 amps or 5 volts. So yeah, so that is how you do those. So you can try out this question. So find the current through each resistor. So find the current through each resistor of the following circuits. So I'm going to put the first circuit as this one. So put a similar one just to test your understanding. Okay, so this is 3 ohms. This is 7 ohms, and that value is 10 volts. Okay. Then 2 here, we have okay, something like that. Okay, and we're going to say this is maybe 6 ohms, and this is 7 ohms, and that is 13 volts. Okay, so you find this. Then the last one that I'll put is this one. So you have I think I can direct you on this one. So there's something like that. I'll just give you a hint on how to work this one out. So suppose we have something like that. Okay, and we've been told that the entrance there is 5 amps. So since there is a junction here, the current that will go through there will be different with the current that will go through there. Okay, so we can say this is maybe 3 ohms, this is 2 ohms, this is 4 ohms, and that is 5 ohms. Okay, then here there is a junction. So find the current that will go through each of these resistors. So here the trick is this. Okay, so the trick is you need to find the total voltage first of all. Okay, the total voltage. After you find the total voltage, you need to note that current 2 will be the same throughout here. Okay, so for you to find current 2, you just need the voltage of the battery over the resistance that are in series, because these are in series, they're connected back to back. Okay, so that is what you're going to do. So this is the voltage over 3 plus 2, which is 5. So the current here will be the same. Same applies here. The current, since these are in series, the current going through there will be the same. So for you to find current 3 as well, you just need the voltage over the resistors in series. So we can say this is resistor 1, resistor 2, this is resistor 3, resistor 4. So we can say this is resistor 4 plus resistor 3. And basically you just need the voltage over the resistors, which is 4 plus 5. And that will be the current going through there. So how are you going to find the voltage? So remember, you just need the resistance total So for you to find the voltage, you have the current total. So the current total is 5 amps. So this is the current that is coming here, then going there. Then now you need resistance total. So you need to find the total resistance here. So first of all, for the resistance total, you have to add these two resistors, which is 5 ohms. Then you also add these resistors because they're in series, which is 9 ohms. Then since now these resistors are in parallel, the 9 ohms and the 5 ohms, you can say 1 over resistance total is equal to 1 over 5 plus 1 over 9. You find the common denominator there, that will be 45. Yeah, plus, so this is 9 plus this, which is 14, and 1 over resistance total. So here the resistance total will be the inverse of this. So it is 45 divided by 15. So 45 divided by 15, which will give me 3. Oh, it's 14, sorry, divided by 14, which is 3.21 something. So this resistance total will be 3.21 ohms. So you found your resistance total, you have your current total, you can find your total voltage, which is the V. So the V will just be equals to the current total times the resistance total. In this case, the current total is 5 ohms. So that will be 5 times the resistance total, which is 3.2. Okay. Then when you multiply these two, so 5, I'm sure it's still there, 2. So that will give us about 16, give or take, so 16 volts. So you found your voltage total. Then you can find the current through each of these resistors. So for this one, you put there, so the voltage is 16 over 9. That will give you current 3, which is the current through the 4 ohms, through the 5 ohms. Same applies here through the 2 ohms, 3 ohms and the 2 ohms. So here it will be 16 over 5. Then you simplify that. So let me write a similar question here. Just write a similar question here so that you can solve it as well. So we have that, we put 6 amps, then we do this. There. Okay, join that. Then this will be what? 5 ohms, 6 ohms, 2 ohms, 1 ohm. So you find the current through each of these resistors, then you will submit your solution. Okay, so you do as wise. So but for now, it's a good evening, it's a good afternoon.